Alright, more equations to solve. These are rational, and so we use cross multiplication where we can. This one will be a nice candidate for cross multiplication because it has one rational on each side of the equals. This one, not so much because it contains three terms, so with this one we're going to multiply through by the common denominator. That will make it stop being rational. So our common denominator is simple enough, it's just x. So we multiply that first term by x, and the next term by x, and the last term by x. And that gives us x times x, plus, in the second term the x's cancel, which is the point of the whole exercise, no more fraction, and on the right side we get 3x. Take this to the left-hand side, and oh look, it's a quadratic. It's not a terribly bad quadratic, it factors without a lot of trouble. And that produces two solutions. Either x minus 2 equals 0, which means x is positive 2, or x minus 1 equals 0, which means x is positive 1. Those are the two algebraic solutions. Are they both valid? Let's see. If we go back to our original expression, what non-permissible values did it have? The only denominator was x, so our only non-permissible would be x is not allowed to be 0. That's consistent with both of our answers. In other words, neither of our answers is a forbidden value, so there's no problem here. If you want to verify your solutions, you have to plug them back into the original and see if they work. The original expression, I scribbled all over it, so I'll write it again. X plus 2 over x equals 3. If x is 2, here's what you get. 2 plus 2 over 2 equals 3. That's 2 plus 1 equals 3, which, after a few moments' thought, you will probably agree is correct. Hopefully a very brief moment of thought. The other candidate here is x is 1. If we use that one, we get 1 plus 2 over 1 equals 3, which is 1 plus 2 equals 3, which also looks pretty good. So both of these answers are valid. That's nice. Now I have to clear some space. I'll try the second one and see if it cooperates as well. Okay. Cross multiplication will solve this. You multiply that way, and you multiply that way. And so you get 2x squared minus 4 equals x plus 2. The order you write these in doesn't matter. I'm trying to put single terms before binomials just because it makes distribution easier. When we distribute these, we get 2x squared minus 8 equals x squared plus 2x. Herd everything over to the left-hand side. 2x squared minus x squared leaves x squared. The 2x comes to the left and becomes negative, and nothing changes about our negative 8. Can we factor that? Two numbers that add up to minus 2 and multiply to minus 8? I believe we can, and I believe the factorization looks like this. X squared minus 4x plus 2x makes that. 2 times negative 4 makes negative 8. Looks good. So the solutions we get are either x plus 2 equals 0, which leads to x being negative 2, or x minus 4 is 0, which means x is positive 4. Are those solutions both good? What are our non-permissible values? From this denominator, we get x plus 2 must never equal 0. Take that 2 to the right-hand side, and you get x cannot be negative 2. Uh-oh. We were saying negative 2 is one of our solutions, and now we're hearing that number isn't allowed here, so just like that, we have to throw out one of our solutions. It doesn't work anymore. Our other denominator was x squared minus 4 is not equal to 0. Take the 4 to the right-hand side, and you get x squared cannot be 4. Square root both sides, and you get x cannot be plus or minus 2. Well, we knew it couldn't be negative 2, so that part isn't news. Now we're hearing it can't be positive 2 either. But that's actually okay. Our other solution has nothing to do with 2, so this new restriction, while it's still true, it doesn't hurt our answers. We still have the answer positive 4, which works. And can I prove that it works? Yes, I can if I write small enough. I'm going to clear out answer A. If you wanted to see that, you'd be in a different part of the video. I'm going to use this space to verify the solution for. So, x over x squared minus 4 equals, we hope, 2 over x plus 2. If I plug in 4s for that, here's what it looks like. 4 over 4 squared minus 4 equals 2 over 4 plus 2. Alright, everywhere there used to be an x, I put a 4 in its place. Now we clean this up. 4 over 4 squared is 16 minus 4 is 12. And on this side, 4 plus 2 is 6. This fraction, if you divide the top and bottom by 4, it reduces to 1/3. This fraction also reduces to 1/3, so yeah, it works. The solution 4 is valid. The solution negative 2 popped out of the algebra, but it turned out to be no good because our non-permissibles said, hey, you can't be that number. This expression blows up if you try to use that number. If you want, try it. So take this expression, and everywhere there's an x, sub in negative 2. See what happens. You'll get some division by 0 weirdness, and you won't be able to finish. You'll end up with an expression that's undefined.